Have you ever wondered what Java is, or programming, or how you go about learning how to code, how to build apps and software to work in cloud and big data? Well, this video is a series of frequently asked questions all about Java for complete beginners. I have our lead instructor, Matt Speake, who teaches the Java for Beginners class, who's going to be answering these questions. So let's get into them. Question number one is, what is Java and how does it differ from other programming languages?
It's a good question. Yeah, so the difference between Java and other programming languages. So pretty much the way I look at it is that each different programming language that you have has its own different purpose, if you like, or which fits in a particular niche. So for example, if you look at mobile development, like for the iPhone, then you're looking at learning Objective-C or Swift. If you look at doing machine learning, artificial intelligence, that kind of thing, pretty much that's typically Python. And if you look at web development type stuff, designing web apps on mainly on the front end, that's actually code that runs inside the browser itself, then you're looking at JavaScript as the main programming language. So 3 different programming languages there, each one with their own different purpose. Now, Java, where Java comes into it, is Java's pretty much like a multi-purpose language. So Java doesn't really slot into one particular niche. It actually allows you to code different types of project, different types of programming project that you do, and it gives you that flexibility to be able to do that. So yeah, that's pretty much Java. And Java's like the #1 programming language currently. It's true that you might have JavaScript and Python kind of vying with Java for the main kind of like leader position, if you like, or the main position on the leaderboard. But pretty much Java's the #1. It's the #1 that's used in industry currently, and it's the #1 that you'll find pretty much powering all kind of like commercial e-commerce sites that you'll come across. So big e-commerce powerhouses like Amazon, for example, Google, Netflix, Facebook, they all use Java pretty much as their backbone to be able to do all of that intensive processing to process all of those different thousands of users who need to access the website at the same time. Java gives you that power and that flexibility. But not only that as well, Java can also be used for mobile development. So for example, with Android, so everything from the cell phone in your pocket with Android, that's built on Java, through to desktop applications like Views, for example, the popular downloader for torrents, right through to cloud-based applications for supporting e-commerce sites like Amazon and Google and that kind of thing. So Java's pretty much where it's at. It's the #1 in industry, and it's a great language to learn. Yeah.
The next question is, do I need to understand how to program in other languages to learn Java?
No, you don't have to know how to program in other programming languages to be able to get into Java. It's pretty easy to do, providing that you do it in a very straightforward, structured kind of way. If you basically learn each concept step by step, then yeah, you can definitely get started with Java and definitely take things to the next level and make that your main programming language. However, if you try and basically, look at everything, look at a complete program in its entirety, in one go, and try and, search things up on the web, how does this work here, how does that work there, and everything, you're probably going to be confused. So it's much better to basically go step by step and just learn each different construct or each different concept, if you like, step by step. So that's probably the best way of approaching Java. But yeah, you don't have to know a particular programming language beforehand. If you do, of course, that's always good, because then you're just basically mapping the existing constructs that you've got inside your head, the syntax that you already know, you're kind of mapping that into the Java language itself. So that's obviously going to give you a head start, but there's no prerequisite for that. You don't actually have to do that. The way I look at it is pretty much programming in general. It's kind of like, you have a problem and you work out a solution inside your head in terms of, for example, this problem here, I need to do this and this and this. So step 1, step 2, and step 3. And then you kind of like decompose that. And you think, okay, well, how can I do step 1? Well, step 1, I need to do, step A, step B, step C. So what you find is that as long as you have kind of like a logical thought process, as long as you can kind of logically break problems down in your head to say, like, to do this, to solve this problem, I need to do this step, and this step, and to do this step, I need to do these sub-steps. As long as you can kind of like decompose problems in that kind of way and just think about things logically and step by step how you'd actually do them kind of like in real life, if you like. That's pretty much all programming is. It's just basically taking that idea that you have in your head and then mapping it into the actual constructs that the programming language gives you. So that's pretty much programming in general. And as soon as you can actually do that, then you can program pretty much in any programming language anyway. Yeah.
The next question is, what kind of computer do I need to be able to program in Java?
Okay, so Java runs on pretty much any system. Part of the big sell of Java, if you like, is the fact that you can write a program once on one particular platform, and then you can run it on any of the platforms. So for example, you could write a program on Windows, and then you can run that on Mac and Linux without having to alter that program at any stage. And that was like a big sell of Java when it first came out, was this so-called platform independence. So that's one of the aspects to what makes Java so popular. But yeah, in terms of actually your system that you use to be able to program Java programs, you can use Windows, so a laptop like from Dell or Hewlett-Packard or any old laptop that you've got lying around pretty much. You can use Mac. Obviously, Mac's my preferred choice because I'm a Mac person. I think it's the best possible option to be able to do programming in, because it gives you so many different tools which you'll use for free completely out of the box. But it's quite an expensive option, so most people don't tend to go for Mac straight away. Normally they've got a Windows machine lying around. And the other option, of course, is Linux. But Linux, pretty much, if you have a Linux system, then you probably wouldn't want to have a course on Java anyway, because you probably learn it all by yourself, because it's a very technical, techie kind of oriented system. But yeah, Windows, Mac and Linux, whatever you happen to have lying around, that's where you can install the tools on which you need to be able to program in Java. And in terms of how modern the computers need to be, how modern the actual systems need to be themselves, as long as you've got something which is pretty much, which is like reasonable performance, and it's like, something which has been manufactured in the last like 10 years, give or take, then you should be pretty much good to go. So Java, you'll find, will actually run on any system. So actually run a Java program that you write as a beginner, it's actually fairly straightforward, and it's not that processor intensive for the machine that you're running it on. So that's perfectly fine. But what you might find is that you need the real CPU, the real processor power that you need is actually not to run your programs, but it's actually to run the IDE itself, which is the integrated development environment, which is the application that you actually type your programs into and debug and run them in. So that's really, what you need the performance there for. But pretty much any laptop that you've got lying around or desktop machine from the past 10 years or so, it's fine. Yeah.
The next question is, do I need to be a math whiz to learn how to program in Java?
That's an interesting one as well, because like a lot of people assume that because programming is a very technical subject associated with like the sciences and everything, and like nerdy people, as it were, then people assume automatically that you need to have a good grounding in maths to be able to do any form of coding, and that's completely not true. In fact, my background is in investment banking, in trading systems development, and you'd be surprised actually about how few people who work in banks actually don't know maths to a reasonable degree. So it's just kind of funny and also worrying as well, I guess. But yeah, in terms of like coming to Java completely as a beginner, coming into the language and learning it completely from scratch, you don't need to know maths. That's perfectly fine. Most times you don't really need to use maths at all when you're a professional software developer, unless you work for example, an investment bank in a very specialized kind of area. Like if you're a quant, for example, quant is somebody who devises mathematical models for how, for example, bonds are priced and that kind of stuff. Then you need to know, you need to be very good at maths, but in general, you don't need to know that. And in fact, even if you write games, which rely on a lot of maths from physics. So for example, when you drop a ball, how does the ball kind of bounce? Or if you fire a bullet, how does the bullet move across the screen, that kind of thing. Even if you write games, you find that you don't actually need to do that much with maths, because there's actually physics engines, which are software components that you can actually use, which abstract a lot of that kind of need to know maths away from you anyway. So yeah, the good news is you don't need to know maths. So yeah.
The next question is, what can I do with Java?
So yeah, what you can do with Java, that's a good question. From a technical sense, you can do pretty much anything with it. So it's almost like if you'd ask somebody, if I have a blank sheet of paper, what type of drawings could I do? What things could I draw? And you could say, well, pretty much you can draw anything as long as you've got a blank sheet of paper. Java pretty much is that blank sheet of paper. It sounds a little cliche, but that's literally what it is. So yeah, as long as your mind can conceptualize the kind of program you'd want to write or what you want it to do, then you can easily take that kind of design which is in your head and break it down into from first principles into the different software components that you need to build and build that up. You can build everything from, as I said before, from the mobile applications, so Android applications which are in your pocket, through to desktop applications using some of the user interface libraries that we have in Java, like Swing and JavaFX. Right through to being able to write cloud-based applications. So these are applications which will run in the cloud on a set of different computers. So maybe like, anything from like 4 to a couple of hundred computers, servers they're called, in a so-called cluster, all running effectively the same program at the same time. The reason they do that, by the way, is because they have to have massive computing power to be able to service all of the different requests that come in from the web at the same time. So for example, if you look at a website like Amazon or Google or Netflix or wherever, then you're not just going to have like 2 or 3 people placing orders every second. You're going to have a few thousand, several thousand, several hundred thousand people placing orders every second. And that power, how you actually get that power in Java is by arranging all these different servers into the so-called cloud to be able to do all of that processing together. So you can really design any application from something in your phone, in your pocket, right through to a huge cloud-based e-commerce website. Everything's possible with Java. That's in the technical sense. In the business sense or the professional development sense, what can you do with Java? You could, for example, get a job in a bank, which would be very good to do. Their pay is very good. Just work your way up the ladder there. You could make your own startup. So you could, create your own software company. Maybe you've got a software as a service which you offer, like where somebody pays, for example, a monthly subscription to be able to access your service. So yeah, think about services like Netflix, for example, or Trello, or Dropbox, other things like that. You can create something like that. You could decide to join a startup. If you join a startup, work very hard, normally you get shares and then you can get a big payout down the line. That can be useful as well. Or otherwise you could just decide to become an indie app developer. So an independent application developer designing apps for Android, for example. And all of those, all shades in between, if you like, all of those are possible with a good knowledge of Java. So it's definitely a really valuable skill to learn in the marketplace, yeah.
The next question is, what kinds of tools or software do I need to be able to write code with Java?
Okay, so the tools that you need, that's a good question. So there are basically 2 things that you need to be able to develop and write Java programs. And the first one is the JDK, and the second one is the IDE. So the JDK is the Java Development Kit. And what that is basically, that is pretty much the Java platform. So it's a collection of commands that you can run and you can execute, which enable you to, for want of a better phrase, do Java. So for example, the 2 main tools in there are going to be the Java compiler, which is the thing that basically takes the Java code that you write and converts that code into a thing called bytecode. And that bytecode is the machine code, if you like, which is then run on a Java virtual machine, a thing called a JVM. And these 2 tools are the main tools that you have in the JDK. So that's the Java compiler, or Java C, and the Java virtual machine, known as the JVM. So without those 2 things, you really can't do Java. But with those 2 things, that pretty much is the Java platform. Alongside as well, having all of the libraries that are collections of code that you can call from within your own programs as well. So that's the JDK itself. On the other hand, you have a thing called the IDE, because the JDK is it's not designed really for humans to use. It's not that user friendly. It's just something that you type commands into the command line into this big black box, and then you get a response back, or the program runs and everything. So it's not that user friendly. So what you find instead is you find that you have something called an IDE. An IDE is an integrated development environment, and that's basically, for want of a better phrase, it's kind of like, think of it as being like a word processor for Java programs. So just like if you want to write a document in Microsoft Word, you use Microsoft Word, you type up your document, and it helps you out by allowing you to do different formatting options and suggesting auto corrections and underlining things if you do things wrong. Similarly, if you're developing Java programs, we have the IDE, which is the same kind of thing. We can type in our Java programs into the IDE. We get help. The IDE will basically, it'll underline things in red if you do things wrong. It'll suggest how you can correct the code if you've written code incorrectly, which is great for beginners, by the way, because it means you're not actually out there on your own. The IDE is helping you along the way each time, which is good. And it's basically a nice, friendly place application to be able to pretty much write, debug, and run your programs. So yeah, an IDE. Two things there: the JDK and the IDE. Those are the two things that you need. And both of those, by the way, are completely free. You can download the JDK from the Oracle website, and you can download an IDE from. There's actually two main IDEs. There's Eclipse and there's IntelliJ IDEA. From the Eclipse Foundation and JetBrains, respectively. And yeah, those are the two things you need. But everything's free to use, and you can download it today and get started writing Java code straight away today.
And our last frequently asked question is, how do I go about getting a job once I understand and know how to program with Java?
Okay, yeah, so how do you get a job after learning Java? That's a good question. So what I'd do is I'd probably break it down. I'd kind of like reverse engineer it. And I'd say, well, what does a professional Java developer, a professional software engineer who uses Java, what core skills do they have? And then you can sort of like, engineer an answer out of that. So as a Java developer, there are kind of like three main skills I think that we have. The first one is core Java. So core Java is basically the ability to write programs in the Java programming language, just in Java, in pure Java, so not using anything else, not using any other frameworks or any other libraries or anything, just in Java. And being able to know how to do that and how to write programs just in Java. So that's core Java. That's the first skill. That's a prerequisite, because without that, you can't do anything else. You can't write more complex programs because you don't have the foundations effectively. That's the first thing. The second skill they have, which builds on that, is the ability to do enterprise Java. So enterprise Java, this is basically where you're not just writing a Java program which runs inside an IDE, or runs at the command line instead and runs on its own. Instead, you're writing a Java program which can connect out to other pieces of an infrastructure inside an enterprise or inside a core organization. So for example, a database, an application that can connect to a database, perform some SQL to some queries to be able to get data back. That's one example. Another example of being able to send a message. If you can send a message to a thing called a message queue or a message topic, which are how different applications talk to one another inside enterprises. That's another example. Another one would be sending emails, the ability to send an email. So enterprise Java basically is where you're not just having one, you don't just create a program which runs, by itself. You're creating a program which can run and connect to different pieces of an enterprise architecture. So different things, different systems, if you like, which run in an organization, or which are available in an organization rather. So that's enterprise Java. And for that you need basically, I'd say there are three core things that you need. You need to know how to write the programs first of all, to be able to connect to the different components, and that's using normally a framework called Spring, the Spring framework, and there's another framework which is off of that called Spring Boot. So Spring and Spring Boot are things which you can use. They basically give you they're libraries which enable you to, or they're a framework rather, which enables you to connect to different pieces of the enterprise infrastructure, like databases, message queues, email systems, that kind of thing, completely for free without you having to write that much code to be able to do that. So a knowledge of that you need in Spring, the Spring framework, Spring Boot. Additionally, you need to be able to build the software. So as projects become more complex, how you build them becomes a little bit more complex as well. And so you need to know a build technology like Maven, for example, Apache Maven. That's the number one build tool currently. Spring and Spring Boot are the number one Java enterprise frameworks currently. And the other thing you need to do then, once you've built an application, once you've written an application and then you've built it, the next thing you need to do is to be able to test it. So then you use the number one test combination test frameworks, which are JUnit and Mockito. So knowledge of Apache Maven, Spring and Spring Boot, and JUnit and Mockito are pretty much the kind of like the core nucleus, if you like, of enterprise Java development. So those are the first two levels, core Java, enterprise Java. And the third level really is about tooling. So it's about knowing how really, how you can use the tools which you'll find in an enterprise. Because when you're in a development team, it's not just you programming a single thing and you just contributing code to that particular project. It's normally multiple developers at the same time working on the same project. And so because of this, to avoid conflicts and people overwriting each other's bits of program code and that kind of stuff, to be able to do things efficiently, there are a set of tools which have been devised over the years to be able to to be able to facilitate that kind of like team development kind of thing. So you need to know about that as well. So yeah, so that's basically core Java, enterprise Java, and the knowledge of the tooling as well. So once you have, at the very least, once you have those two things in place, the top two, core Java and enterprise Java, you could then start to write your own applications and upload them to a site like GitHub, for example, where you could then subsequently give a link out to the code that you've written, so the projects that you've written, out to prospective employers, which you might find, for example, on LinkedIn or on some of the various job sites like dice.com or jobserve.com over here in the UK, or Indeed, I think is another one as well in the US and Canada. And you can say, look, I haven't been in the industry before, I've just started and everything, but I'm really keen on this. Here's an example of some stuff that I've done. Then at that point, they can bring you in for a technical interview. And as long as you've done your homework, as it were, and you've actually got a good knowledge of those foundational kind of concepts, core Java, enterprise Java, and to a lesser extent at this point, the tooling, then at least you could move forward to like an interview. And then, yeah, you might be able to like slot yourself into an enterprise, which would be a fantastic career move. In order to do that, of course, you do have to put the work in, and you do have to understand things, the foundations at a good working knowledge kind of level. But it's really being able to get the break to be able to get into those kind of companies. And the best way of doing that, in fact, wouldn't be to target, for example, like let's say the top tier companies first of all. So I wouldn't target banks or any of the Fortune 100 or Fortune 500 or whatever. Instead of that, I'd probably go for kind of medium-sized enterprises, small to medium-sized enterprises who need Java developers, because they'd be more likely to take you on without having as much experience or as much, let's say, qualified experience, like a degree, which is what you usually have to have. They're more likely to take you on in that respect, mainly because banks and such organizations, they have certain compliance that they have to meet, so they have to be seen to be very stringent in terms of their standards. So if you can basically slot yourself in through a small to medium sized enterprise, that's probably the best way to get started and to be able to cross over into a career as a software developer. Yeah.
All right, I hope this series of frequently asked questions has helped provide some more information about Java. And if it has sparked that interest in you, we hope that you consider enrolling in our Java for Beginners class. It's the perfect way to get started learning how to code with Java. I'll include a link in the description of this video where you can get a discounted enrollment to start learning Java today. In the description, I'll include a discount link so that you can get started today. Thanks so much for watching, and have a beautiful day.